sheet metal functionality within SolidWorks is a powerful way to create bent, cut-from sheet components ready for manufacture. Usually, sheet metal parts are designed in their folded state, and with the click of a button, the flattened profiles can be extracted to create 2D drawings or be sent directly to a laser cutter for profiling. There are three main approaches to creating a sheet metal part: using sheet metal features such as base flanges, edge flanges and miter flanges, inserting bends into an existing thin-walled part, and converting to sheet metal, which allows a sheet metal wrapper to be created around the faces of a non-sheet metal body. Each method has its own benefits, but by far the most flexible is starting with a base flange and adding features to it. So let's start by taking a look at this method. Before getting started, to access any sheet metal features, the sheet metal tab will want to be enabled. If this isn't visible, right-click on any tab on the command manager whilst within a part file and choose Sheet Metal from the tabs menu. The Sheet Metal tab will then appear. The base flange method starts by creating a 2D sketch. This sketch can either be enclosed, such as a rectangle, or open, such as a single line or channel shape. Whether the sketch is open or not will determine how the base flange feature is created. When a base flange is created from an enclosed sketch, the sheet metal thickness is created perpendicular to the sketch plane, with the end result being a piece of sheet metal which has no bends. When a base flange is created from an open sketch, such as this channel shape, the sheet metal thickness is offset about the sketch. You'll notice that I don't need to add a radius on the corners of my sketches as the bends are automatically added. Using the open sketch approach often allows a greater amount of information to be captured and can make it quicker to create a sheet metal part and easier to update later on. It's a good idea to think about your design intent and the driving information you have before deciding on which method is best to use. Unlike the base flange method, insert bends requires a solid, thin-walled geometry to already exist that can have bends added to it, which in turn creates the sheet metal part. This method can be useful when the final shape is complex or includes angled flanges that create a mitered corner. To turn a solid shape into a sheet metal part using insert bends, it firstly needs to be shelled, which gives a consistent wall thickness. Then the insert bends tool can be used. The first selection defines the fixed face of the sheet metal part. When flattening the shape, this is the face that will stay still, and the other faces will unfold around it. Rips also need to be selected. Rips are the edges that will create a gap between any two adjacent flanges. When selecting an edge to rip, Change Direction button can be toggled for each selection, and this defines whether the corners will be butted, indicated by the two-way arrow, or lapped in either direction. Convert to sheet metal is similar to insert bends in the fact that it requires existing geometry as an input. However, this geometry does not have to be thin-walled, as the sheet metal thickness is defined within the Convert to Sheet Metal feature. The starting point for Convert to Sheet Metal is a solid body. Usually, this would be modelled within SolidWorks, but you could also use an imported part. Like with insert bends, one face needs to be selected as the main base flange, but then any edge selected becomes a bend from which a new flange is added. Each of the methods mentioned have a number of properties available when they are created, and these include options such as sheet thickness and bend radius, bend allowance and relief. The sheet thickness is the thickness of the sheet metal that is to be created. Bend radius is the internal radius that is created when a bend or flange is added. Bend allowance is either a value or a calculation that is used to determine the length of the flattened sheet metal part. This value will change depending on bend angle, bend radius, material and sheet thickness. Sheet metal manufacturers should know these values, but for engineers designing sheet metal parts, be careful when supplying flattened parts for profiling and laser cutting, as an incorrect value here will result in an incorrect part. Relief controls how the corners where two flanges meet is treated. This can be set to tear, ob round or rectangular. Depending on the complexity of the part, additional features may need to be added to the sheet metal component, and this could include flanges, hems, jogs, and a variety of other features. Secondary features inherit the properties that have been set within the initial sheet metal feature. So for example, the sheet thickness of a flange will always be the same as that of the main feature. Some properties can be overridden though, such as changing the bend radius for a specific bend when a new flange is added. At any point during the design process, the flattened version of a sheet metal part can be shown, and this is done by clicking the flatten button. SolidWorks sheet metal will only allow features to be created that can be flattened. So if features are added that can't be, errors will appear in the feature manager. The flattened version can also be easily added and detailed within 2D drawings from the view palette on the right hand side. As you can see, sheet metal is a great tool for developing folded parts within SolidWorks. I hope you found this video useful, and remember, if you want to create interactive 3D presentations from your SolidWorks data, make sure to check out Cadacio.com.